let's mount our vise. But before we do so, I'd like to show you again a couple of tips and tricks. This is a swivel base that we can see mounted on the bottom of our vise. It allows us to turn the vise left or right to set up an angle that we may want to machine. You'll notice we've got two slots that are machined by the manufacturer in the bottom of the base. In order to locate this base quickly on our mill, we simply would machine two rectangular bars that precisely fit inside these, lock them down with a 1/4-20 screw that's drilled and tapped, provided by the manufacturer, and then these slots would mate into the T-slots in our mill bed. So if you get a vise of this type, a good little project for you to do in the evening is machine a little bar that goes across here and approximately a 1/2 inch deep. Drill and counterbore it for your screws, mount it to the bottom of your swivel base, and that way it facilitates installing the vise on the mill. Make sure we wipe the base of it off. Make sure that we wipe the mill table off. We don't want any chips or debris between the vise and the mill table. I like to give the bottom of it a shot of WD-40 or any type of spray oil before we mount it, just as a corrosion inhibitor. Vices are usually pretty heavy, so get a good firm grip on it. We want to center it on the bed. Do not drop it on. Slide it on gently. Grab a tape measure because we want to mount the vise in the center of the bed. If you have a special application where you're going to be using a lot of tooling, it's not a problem to mount the vise to the left or right, allowing us a much broader bed space to use our clamp setup, special fixtures that we may build that can be worked in conjunction with the mill vise as a second operation. So keep that in mind depending upon the type of work that you want to do. We've got 16 3/4 on that side and 14, so about 1.5 inches to the right here ought to do us. Another 1/4 inch. All right, so their vise is centered within a 1/4 inch or so on the table. The next thing we'll need in order to mount the vise correctly are two threaded T-slots. We're going to mount those in the center section of the bed in the T-slots. Push them up towards the cutouts in our swivel base. We're going to need two 1/2-13 studs. It's important when you're mounting a vise that has a swivel on it that we use as short a stud as possible, because when we loosen the vise in order to pivot it left or right, it must clear our nuts that hold the swivel base to the vise and to the bed. Push them in towards the center. Since we don't have the slot on the bottom to guide us in, a quick reference again is just push the vise, take out the slop against our studs, and we're now ready to mount our flange nuts on the top. Remember, the flange nut has an integral washer. Really a high quality, hard, heat treated nut that adds a bit of professionalism to the mounting setup. You can see just finger tightening them, we've got a real clean, sharp looking vise mounting in process. Alright, I like to just kind of snug them up a little bit with the wrench. Not very tight because we're going to do a little bit of tapping here in order to get the vise properly aligned. Kind of take the heel of our hand, and if we're to hit our vise, we can adjust it left or right. Now, let's lower the bed, and does anybody remember what axis we're operating in now? All right, you guessed it, the Z axis. We're going to lower the bed a little bit. We'll put in a 3/8 collet, and I'll show you a neat little trick to align the vise quickly. We're going to take a standard 3/8 end mill. You can use a piece of 3/8 inch round stock, and we're going to insert the end mill upside down in the collet. Grab our wrench, tighten it down, lower the quill, and bring our end mill stub to about the center of the vise. Okay, lower it down about 1/4 to a 1/2 inch. We're just going to come in contact with the vise jaw, the back vise jaw now. We'll pull this jaw away a little bit so you have a little better view of that. Remember, we did not tighten the nuts down. We simply snugged them down with our wrench a tiny bit, or just finger tight is more than adequate. Now, we're just going to work the what axis? For those of you that guess the X axis, here on top of the game, left or right on the vise jaw. And if we're out at all, we can see it behind the end mill as a little gap, piece of light that's showing up. We can take the heel of our hand or we can take a plastic hammer and we'll just tap it and about split the difference in the light. Okay, we're right there. We have contact. Now we'll go ahead and run that across one more time. And as what we're doing is just basically roughing in the vice jaw at this point. It's a real quick and easy way. Saves us a lot of time dialing in the vise. With that done, we're going to take our wrench and just snug them down a little more. Again, not too tight. We still have to make that final adjustment in order to get the vice jaws dialed in. The old mill's falling apart on us here. We better give it a little bit of maintenance. Now retract the quill. We'll take the end mill out of the collet and we're going to install our dial indicator for this next operation. Little stare at best test is the type of dial indicator that we're going to be using, and we are going to need a 3/32 R8 collet. These are our collets again. Bridgeport type machines are going to be taking an R8 type collet. Remember to buy good American-made collets if you can. This particular brand is a Hardinge. Hardinge builds probably some of the finest machine accessories in the world. Okay, we're going to install our 3/32 collet. We'll take our test indicator. Always be sure to tighten the collets. We want a good firm grip on the dial indicator. We don't want any shifting of the indicator in the collet, which can affect the accuracy of our vise mounted on the table. Bring it down about 1/4 to 1/2 inch below the top of the vise, and we're simply going to preload it. Watch the dial indicator now as we come in contact with the vice jaw. Okay, we're going to preload it about 10 thousandths. Okay, and now from right to left, we're going to advance the dial indicator across the top of the vice jaw. Okay, you can see by using the end mill method, which is a neat little trick, we've brought that vice jaw within 2 thousandths of parallelism to the x-axis of the mill bed. Very, very close. You'll see folks that'll spend 20-30 minutes, almost as bad as trying to tram in the head, by not using that little trick with the end mill. So now with a plastic hammer, we're going to take and tap on the left side of that vise, pulling it towards us a little bit. We're going to split the difference. We'll tap it till we read about 1/1000 out. Move the bed clear to the other side. And I think it's important anytime we dial in the vise that we always move in one direction, because we're going to get a little bit of torque out of the dial indicator. Take it back to our 0 point. Again, preload it to 0 or 10, whatever we have on the indicator. It doesn't matter. We can set our bezel ring at 0 if we so desire. And then we're going to work from right to left again and see just how close we've dialed in that vice jaw. Okay, we've got that vice jaw parallel to the axis of the bed within about 2/10,000ths of an inch. More than adequate for 99.99% of the machine work that we're going to be doing on a vertical mill. So now, very gently, we're going to take our wrench and tighten down those base nuts. Very gently. Don't scrounge down on them at any one time. We want to progressively tighten them so the vise does not shift. Okay. All right. Now let's go back and just check one final time now that we've secured the vise and make sure that it hasn't shifted during the tightening process. Back your dial indicator out, preload it again to a designated number, and again travel from right to left and watch the needle on our dial indicator. All right, we're maintaining about 2 to 3/10 on that operation, so now we're ready to go. We'll simply remove our dial indicator. I'll show you another neat accessory and how it applies to the mill. It protects the mill and it gives us a great working platform. Okay, we'll call these the Darrell Holland way covers, if you will. All right, we made them out of 1/4-inch masonite. You can see we put a couple little guide rails on the bottom of them so they fit into the T-slots in the mill bed. We're going to set these on each side of the vise. So now we've got a great work table. If we want to set or drop a wrench on the table, we're not damaging the mill bed. Very, very important. You'll see a lot of folks in machine shops, they've got big cutters, vices, different accessories that they're working with, and they're just constantly banging them and dropping them on the mill bed, putting all kinds of nicks and dinks, so they're constantly being forced to resurface the top of the machine. Treat your machine as you would your wife, with a lot of pride and gentle care, and it'll last you literally a lifetime. Great project to build in an evening. They'll take you approximately an hour to do, and they'll go a long ways to making you a master machinist. All right, with our vise dialed in, this is probably the most useful tool that you can have on the milling machine. This again is a Kurt Angle Lock 5-inch vise, precision ground jaws. When we tighten a Kurt Angle Lock, it's important to know that the vise jaw pushes in and down at the same time. So we hold that part securely in the vise. You'll see a lot of Kurt Angle Lock knockoffs that are out there, not nearly the quality of vise. You're going to spend $100, $150 more to get the real thing. Long after you've spent that money and you're producing quality parts, you'll sit back in your easy chair while you're counting your money and you go, yeah, that was a wise investment. So buy good accessories. Kurt Angle Lock vise is the way to go for your milling machine. The swivel base is going to cost you approximately an extra $100, $125. If you're going to be doing a lot of swivel and angle work, I strongly recommend that as an accessory to go with your vise. Now let's take a look at some different procedures that we can do in using the vise in mounting our workpiece. It's really important to keep a rag or paper towel in your pocket. We want to constantly be wiping the jaws and the base of the vise clean. We don't want any chips or debris that may affect the accuracy of the parts that we're about to machine. These are precision ground parallels. Parallels usually come in sets of 2. We're going to use these to support different workpieces. They set in the vise, providing again a stable parallel platform to the vise, allowing us to grip and grab different things. Let's say that we were going to machine or grind on our 1, 2, 3 block and we needed to set it up above the vise. They work really well. They hold the part parallel. We can come in, machine around the corners, whatever is necessary. Parallels are an invaluable thing. We can also use the 1, 2, 3 block as a spacer or a parallel in the bottom of our vise. Make sure and wipe it clean. Set our parts. We can use it to set our vise in place as well. Remember, we talked about this earlier. Having a secondary vise like this that we can hold at 90 degrees to the vise. We're now ready to go and apply, clamp different parts that we may find necessary. We can use the sign bar again to simply change the angle of the vise. Again, for a second or third operation, having an auxiliary vise is really handy. Our V-block fixtures, again, really shine in this type of a vise. Remember, this is the Brown & Sharpe style V-block that is either a vertical or horizontal V-block. Simply install it in the vise, snug it down. Again, we don't want to try and mash the V-block, just snug it tight. This is a nice little speed handle that you can get as an accessory for the Kurt Angle Lock vise. We're now perpendicular within 2/10 from this precision V-block. We've got our clamp in place. We can come along and machine and do whatever we need to on this little bronze part that's mounted in the V-block. So now I think you're getting to understand the versatility of a good vise on the machine. It's your third hand, if you will, in any milling operation. Always check to make sure that it's clean. From time to time, go back and check. Anytime we're doing a critical job, make sure that our vise is mounted parallel to the x-axis of our mill bed. Very, very important. If it's not, make whatever adjustments you need. We want to have a run out error of less than 1/1000ths, okay? 1/2 to 2 or 3/10, in my opinion, is really ideal. Anytime that we start running 1/1000ths or more out as we get out on a long part, we're going to have something that's not machine true or parallel, depending upon our application. All right, that pretty well covers our vise applications and what we can do with the vise. We've talked about parallels, the 1, 2, 3 blocks, the importance of keeping the vise clean, free from chips and debris that may affect the accuracy of our machining process. Now, it's time to move forward. Oftentimes, we're called upon to work on, machine modify oddball parts. Again, we want to use our creativity in order to establish a reference point for machining those parts. Some of them can be a real pain in the tail, and unless you look at them with an open mind, they can be quite frustrating. Let's look at a gun stock, for example. On a gun stock, very few things are parallel, very few things are 90 degrees to one another. So a simple way to locate a gun stock I've found is to just set a parallel on top of the vice jaw. Then we're going to get down on the side and simply adjust our stock, the top line of the stock, in order to match the edge of the parallel. And when we do so, we simply snug up our vise. Now, that gets us level, but we also need to look at the other axis of the stock, and that is the top of the stock. Is it flat and perpendicular to the world? So at that point, again, we would simply put a parallel, a straight piece of steel, whatever you have. Parallels work fine. We know that they're flat and true. Set it on top of the stock. Again, we're going to come back from the vise. We can simply loosen the vise, make our necessary adjustment. In an extreme case, we'll show maybe that the stock is tilted this way. We can simply rotate it back until our eyeball tells us that the parallel on top of the stock is parallel with the top of the vice jaws. At that point, we can simply tighten the vise. If we want to get really precise, we'll simply install a dial indicator in the quill and run it over the top of the parallel and then make any necessary adjustments that we have. Something that I've found quite frustrating over the years is the ability to hold something that is tapered. The forend of a gun stock also comes to mind. You can see how much wobble we have. We're contacting at the back of the stock, but we don't have anything to grip it on the sides. Having different types of vice jaws will come in handy for that. This is a set of leather vice pads. You can use leather, carpet, cardboard. Again, use your imagination. We're simply going to install those on either side of the stock. If you have a minute amount of taper, the compression of the leather pad will allow it to grip. But again, in this case, we've got a lot of taper. Our stock still wobbles around. We can't get a good grip on it for machining. Make yourself a couple of little aluminum tapered shims. You can make them out of aluminum, you can make them out of nylon. We're simply going to insert those along the sides of the stock. Push them in evenly with your finger, and now we tighten the stock up, and it's just solid as the Rock of Gibraltar at that point. Okay, so that's a very important tip in holding oddball tapered parts that we want to machine. And again, making sure everything's true, we can just set our parallels on top of the stock, make whatever adjustments we can to machine out the barrel channel for a larger part. While we're on the topic of vice jaws, let's take a look at a set that I machined for holding some special parts. This is a set of vice jaws. Bolt directly to the Kurt angle lock vise. We'd space them apart. They were for holding 3 round cylindrical parts that needed the same machining operation performed on them. So if we were to set them in our vise, simply insert our parts, clamp them down, make that machining pass, unload them, 3 more. Again, it's a neat little production fixture that you can do quickly and easily for processing a lot of parts. They don't necessarily have to be round holes. They can be a rectangular slot. Whatever it takes to hold that specific part. Remember, we don't want to get so tunnel visioned or tunnel focused in what we're doing that we fail to exercise creativity in the machining process. Whether it comes to holding a part or fixture, always be flexible in your approach. All right, here's a good example of a part that sometimes is difficult to locate. We've got a round cylindrical part with a flat on it. We need to machine more off of this flat, but we set it in the vise and we're going, gosh, how are we going to get that flat perfectly flat and parallel to that surface? Well, here's another neat little tip that you can throw in your bag of tricks. Simply bring our vice jaws up close. We can use a 1, 2, 3 block or another parallel. Bring the quill right over the top of the parallel on the vice jaws. Get my stop off here and we'll be with you in just a second. Right, we're simply going to lower the quill. You can do it up against the collet. You can do it right across the top. We're going to loosen the vise to where our 1, 2, 3 block or the parallel sets right on top of the vice jaws. Simply compress the quill down against the top of the parallel or 1, 2, 3 block, and we're now going to take this flat and align it to the block. Set it in, rotate it. You can look at it from the front there. Right at that point, we're in full contact. Take our finger, hold it in place, gently tighten the vise, loosen the quill, and now this surface is absolutely parallel to the top of our vice jaws, and we can go ahead with the machining operation. Another thing that comes to mind, let's say that we have a real thin part that we need to machine. We don't have any parallels that are thin enough to support it in the vise. Simply take our fishtail, a 6-inch scale, set it on top of the vice jaw, and then we can use that as an alignment tool. Simply compressing the part down with our hands or with the quill until we mate perfectly with the scale or whatever shim that we've applied to the top of the vise. Okay, again, very, very precise method of locating a thin part using a 6-inch scale or using the little fishtail again as a shim. If we want to set a little bit of an angle, again, we're producing a part that's not really critical. They've got to mesh together. We find, wow, we just need to taper it one direction or another. Simply loosen the part, set our scale in on one side. We're going to flush it out on one end and maybe give ourselves 10 or 15 thousandths on the other. It's a very precise way of adjusting that depth in order to machine the part to Farmer Brown's satisfaction. Not every part that comes in the shop is going to be an aerospace part that we can hold in a specific fixture, dial indicated in, use the coax indicator in order to find the next machining reference. Sometimes we have to think, be creative, come up with different ways of holding parts. A good pair of cardboard jaws is also something that's nice. We have a very delicate part that we don't want to crush. Simply insert those into place. We can clamp a finished part with them without damaging that surface. Remember, paper is extremely uniform in its thickness. This is not an advertisement. This is just simply a little trick. You can use a piece of paper to shim between a part as well. Keep in mind that paper is extremely uniform in thickness. If we've got a highly polished part that we want to protect, we simply can insert it into our vice jaws, make sure they're clean, clamp it down, and now we're protecting that surface from any chips or debris that we may crush or imprint into the side of our part. We can also use paper as a shim. If we have a part that has just a slight amount of taper and we clamp the vise on it and we find, wow, we've just got a little bit of rattle to it, simply take a little shim of paper, open our vise up, we'll just shim in that one side, tighten it down, and now we've got a very solid work support system. If the edge was really critical, we can simply take a dial indicator, run it over those edges, offset our vise on the swivel base, and align it correctly for the machining operation. Another thing that comes to mind is the use of a woodruff cutter. Oftentimes we've got a large piece of material that we clamp in the vise. We don't have any parallels that are 10 or 12 inches long, and we want to get a flat surface or get it at 90 degrees to the cutter. So we would simply install our part, lower the quill down with our cutter in, and simply sight down to the bottom of it, or in this case, we'll simply loosen the vise, bring the cutter up to contact with the bottom of the woodruff cutter, very gently tighten the vise. Now we've got perfect alignment, perfect perpendicularity of the part to the spindle. We're ready for the next machining operation. Now here's a real oddball. We've got a finished part. It's a round cylindrical part. For those of you that deal in the firearms trade, you'll probably recognize this as our triple baffle quick discharge muzzle brake. Suppose you want to do a secondary machining operation on the part. This was machined off of a fixture that rotated it 90, 180 degrees to machine the different baffle plates and holes. But let's say that we want to change it and we're going, wow, God, this is really an oddball part. How am I going to hold it? How am I going to enlarge these holes? Here's a simple trick. We know that when this part was machined, it was machined and these parts are going to be symmetrical and uniform. We're simply going to use those as our base reference. Every part that you encounter in the machining trade that's been machined is going to have some type of reference that we can use to set the part up with. I would use one of the baffle slots. Simply take a square, set it in the bottom of our vise. This is where you need to be a little bit ambidextrous. We're going to take our index finger, holding the square down tight against the base of the vise. And then we're going to just rotate our part along the baffle using the top and bottom edge of that baffle to align with the vertical plate on the square. And then simply reach up, tighten our part in the vise. We've now properly aligned it for the next machining operation. We can take our edge finder, come in, contact the part, index over to the center, enlarge the top ports, whatever we may want to do. Again, it's another example of how to take something, find out a reference point, align it in the vise or tooling fixture for the next machining operation. All right, that's just a few of the tips and tricks that we have on holding different oddball parts. Let's move on.